What's up? What's up? It's your man Jimmy Chan. All right, so we're now talking about functions and graph of functions. So we have relations, right, which is corresponding between two sets x and y, right? X is the domain, while the y is the range. We already know that, right? So it's a relationship if each domain has its own range, right? Each output has its own. Each input has its own output. So range is all the possible y values, which is also known as the dependent variable, while the domain is all the possible x values, which is known as the independent variable. Domain is what's usually going to be asked anyways, unless of the range. The domain is typically negative infinity to positive infinity, which is known as all reals, unless you see fractions or you see radicals, especially with the eventh root. With fractions, the denominator cannot equal to 0, and with the radicals, the radicand has to be greater than or equal to 1. All right? So let's take a look at some examples, some possibilities here. So let's say, for example, that g of x is equal to x divided by x squared minus 144, right? What I know is that this denominator x squared minus 144 cannot equal to 0. So, however, I know I can factor the left side because that's the difference of two squares. So that's going to be what? X minus 12, x plus 12, and that cannot equal to 0. So that means x cannot equal to 12, and x cannot equal to negative 12. So those are my two restrictions. So I can use any other number except for negative 12 and positive 12. So therefore, my domain is going to be from negative infinity to negative 12, not including negative 12, union with negative 12 to 12, union with 12 to positive infinity. That whole thing will be my domain because it's telling me right here that I cannot use negative 12 or positive 12. That's why it's not included in my answer. Okay? So the next example, which says f of x is equal to the square root of 3x minus 24. Okay? So what this tells me is the radicand, right? The radicand the 3x minus 24 has to be greater than or equal to 0, right? So if that's the case, then let's solve that. So I got 3x is greater than or equal to 24. So x has to be greater than or equal to 8. All right. So if that's the case, then my domain is going to be from 8 all the way to infinity because it's greater than 8. So that's why it's going to go towards positive infinity. All right. But what if we had another example? What if we had f of x is equal to 9 over the square root of x minus 4? Would we say that the x minus 4 has to be greater than or equal to 0? Can we have a 0 in here? I can take the square root of 0, but can I have the square root of 0 down here in the denominator of the fraction? The answer is no, so we can't use the equal to 0. We actually have to take away that equals. So x minus 4 just has to be greater than 0. So that means x has to be greater than 4. If that's the case, then my domain is going to be from 4, not including 4, all the way to infinity. And there you go. All right. Okay. On to the next. So when do we know when a function is not a function? Well, it all depends on what we're given, right? If we're given a bunch of points, then if the x repeats, then it's not a function. If we're given a graph, if it fails a vertical line test, it's not a function. If we're given like an equation as a function, then we gotta first solve for y. And if any x can give you more than one y, then it is not a function, okay? And typically that would be something like right, something like this. I'll put it as an example. This is a very simple example. So let's say, for example, I have to solve for y. So to get y by itself, I have negative y squared is equal to negative x plus 5. Multiply everything by negative 1. So I'm going to have y squared is equal to x minus 5. Then I have to take the square root of both sides. And when I take the square root, I have to have the plus and minus. So that plus and minus, so I'm going to have y is going to equal to that plus and minus square root of x minus 5. So this plus and minus tells me whatever x I put in here, I'm always going to have a positive answer and a negative answer. So that means I'm going to get two answers. So that's why this would be not a function. All right. All right. Onward we go to operations. Hey. Okay. There we go. All right, so with operations, what you see is with functions, we can add them, subtract them, multiply them, divide them. So most of the time, what you're going to see here is that what they want to do is have you divide them and then having to find the so-called domain for them, right? Now, some of this is kind of important. So let's say, for example, if I'm given a graph, like so. So whenever we dealt with f of x and g of x's, we typically dealt with a given function, right? a given equation. So let's say, for example, that they want you guys to look on graphs, right? So they could say, hey, I want you to find f plus g of 3, right? So this tells me that I have to find the f of 3 and find the g of 3 and then add them together, all right? So here I need to find 3. 3 is my x value. So here's my 3 is my x value. Okay. No, actually, I don't need the arrows, but there it is. So that's my x value. So what's my y value? Well, it hits the red line right here, right? So my f of 3 is -1. And my g of 3, well, it hits the blue line right here, right? And that y value is 4. So I have to add them together. So that's going to equal to 3. So f plus g of 3 is going to be 3. Okay. So from there, I can do the adding, the subtracting, the multiplying, dividing. Okay. And however, if they want to keep it in equation form, essentially that's what I had up here, is that you can look at this as a f of x divided by a g of x, right? Same thing here. You can look at this as a f of x divided by g of x, or a 9 being f of x, and then g of x is 1 over the square root of x minus 4. So there's a bunch of ways to look at it. But again, it's just as simple as adding, subtracting, multiplying, dividing. But the whole purpose is usually, after you find them, what the heck is the domain? All right? All right, so we're now to the difference quotient, which is given by f of x plus h minus f of x all over h. Okay? So essentially, this is something that is usually given to you, but you just have to take care of it. Okay? So for example, if they tell you that f of x is equal to x squared minus 2x plus 2, okay? And they want you to find the difference quotient. So in this case, f of x is already there. I have it, right? What I need to find is f of x plus h. Which all this is telling me is that wherever x is, replace with x plus h. So I go, okay. So I have squared minus 2 times plus 2, which I have to replace the x with x plus h. So this one here, I do have to FOIL out. And when I FOIL this out, I'm going to have an x squared plus 2xh plus h squared minus 2x minus 2h plus 2. So there I go. So this is f of x plus h. So again, let's reiterate. So what I have here is, for the difference quotient, is I have this minus this, and then divided by h, which we have all of them, right? So if I did that, that would be this right here, which is the f of x plus h. Seems like it takes so much room, right? And then I got to minus, I use the parentheses here, which is, ooh, I still run out of room. What do I do? What do I do? Oh no. Oh, I can shrink this a little bit. Bring this over here a little bit more. And get it over here. There we go. X squared minus 2x plus 2 all over h. All right? So let's take a look at what that gives me. All right, so actually, it's probably a better idea if I just put it down here. So this is going to stay as is. Okay? However, I have to distribute this negative through. So what I'm actually going to have is a negative x squared. I'm going to have a plus 2x, and I'm going to have a minus 2. And this is going to be all over h. So if you notice, the f of x cancels itself out. So what I'm going to have left is 2xh plus h squared minus 2h over h. And what I can see here is that there's an h as a GCF up top that can come out and cancel with this h here. So what I'm going to have left is a 2x plus h minus 2. And that, ladies and gentlemen, would be my difference quotient for the x squared minus 2x plus 2. Well, I hope that helps. If there's any questions, please let me know. See ya.